Hey, Dan Wallach here.
Welcome. Good morning, everyone. My name is Ben Hovland, Commissioner of the Election Assistance Commission and the Designated Federal Officer for the Technical Guidelines Development Committee, or TGDC. The TGDC is a 15-member advisory committee established by the Help America Vote Act to assist the Election Assistance Commission in developing the voluntary voting system guidelines. Pursuant to HAVA, the Director of the National Institute of Standards and Technology, or NIST, serves as the chair of the TGDC and requires NIST to provide the TGDC with technical support necessary to carry out its duties. The Director of NIST, Dr. Copen, is unable to join us today. However, he has designated Mary Brady to serve in his capacity today, and we welcome her. This meeting is called pursuant to the Federal Advisory Committee Act and has been noticed in the Federal Register and published on the EAC website for today's meeting. This meeting is open to the public. The discussion today is our second in a series of 3 calls on the technical requirements that are currently being drafted by NIST to complement the VVSG. Today's discussion will be on the sections on high quality design, high quality implementation, transparency, and interoperability. We thank you for your attendance and participation today and look forward to a rigorous discussion. I'd like to offer Mary Brady from NIST an opportunity to share opening remarks before we get into the business of the meeting and before I pass the meeting over to Jerome Lovato from our testing and certification team for remarks. After remarks from NIST and represented NIST, or after Mary Brady's remarks and Jerome will conduct a roll call of the TGDC members and open the meeting for business. Thank you. Mary, do you have anything you'd like to say?
Just a couple comments. Thank you, Ben. First of all, good morning, everyone. It's still morning, I suppose, and welcome to this the second in a set of 3 calls on the TGDC or the requirements for the VVSG 2.0. I'd just like to point out that one of the primary reasons that we're holding these calls is so that we can get feedback from the TGDC members prior to the in-person meeting in September. So our hope is that the call will be a bit more interactive than the last one, and that we'll get some feedback from you all. And the reason for that is we still have some time to make some changes in the requirements depending on your feedback. So we'd really look forward to increased participation from the TGDC members. And please, I know this format is a little bit different, a little bit harder than an in-person meeting, but we really are hopeful that we can get additional feedback from you. And I think with that, happy to be here, glad to have all of you on the call, and we look forward to today's conversation.
Thank you. Jerome, is there any housekeeping that you need to take care of? Or?
Yeah, so for the TGDC members who have called in on their phone and not on a WebEx app, you could just identify yourself, because on our end, WebEx determines you by calling user and then some number. So if you are a TGDC member who has just called in and you're not on the WebEx app, will you just please identify yourself?
Hey, Jeff Scott, Smartmatic.
Okay. So I'm going to, I guess, Cliff, did you want to do the roll call?
I'll do that, Jerome.
Okay.
All right, so we're going to go through the roll call now, and if people can acknowledge if they're present. We know that Dr. Copen has Mary Brady here in his place. Bob Giles, Paul Lux, Linda Blamone, Neil Kelly, Mark Guthrie, Sachin Pavitran.
I'm here.
Thank you. Mary Saunders. It looks like Mary's on, but maybe we can't hear her.
Can't you hear me?
Oh, great.
I'm here
now. Thank you.
Okay.
Gloria Gino. I believe Lori emailed to say she's on the call, but maybe we can't hear her either. Judd Choate.
Lori is here. Are you able to hear me?
Oh, great. We are now. Thank you.
Oh, cool. Thank you.
Thought I saw Judd on here as well, but I did not hear him respond. Looks like he is muted. Don't take offense.
I'm very offended.
Oh, great. There you are.
All right. Thanks.
And moving on, McDermott Coots, Diane Golden.
I'm here. Hopefully you can hear me this time.
We can. Thank you.
Perfect.
David Wagner.
I'm here.
Welcome. And Jeff Hale.
I'm here.
Great. Thank you all. I think that covers our list.
Okay.
You didn't mention Dan Wallach, but I'm here.
Oh, sorry. I heard you earlier. Thank you, sir, and welcome.
Okay, so I'm going to just hand this over to Ben Law from NIST right now.
Thanks, Jerome. So I can go ahead and share my screen?
Yep, you should be able to now.
Okay, 1 second, please. And
We see it. Thanks, Ben.
okay, great. Good morning, everybody, and thank you, Jerome. So my name is Benjamin Long. I work at NIST with Mary Brady's team and myself and John Wack, who you all know very well. We will be presenting on the draft core requirements that have been developed to date on VVSG 2.0. So since there's a large volume of material and we wanted to give you guys a context for these things. So those of you who were at Sharon's recent talk, she sometimes had the opportunity to read through a number of requirements. And what we will do is, due to the volume, we will put requirements squarely in context, and we will have them available if you want to zoom in further, and that will be kind of our overall strategy. John and I are going to be co-presenting today, so we'll take turns on various slides or tag team as the case may be. So what I'm going to do is kind of open up, kind of like Sharon did in the last call, just give a little bit of brief context before we dive in, just to set the stage. So over the past few years, you guys may remember, I believe it was certainly as VVSG 2 got going, there's been a process-oriented focus. And then certainly in 2017, the EAC presented the well-known EAC 17 functions. And so this standard and its requirements have been reorganized around that process idea and around the idea that a voting system can be understood as a configuration of election process functions and technology, and that those processes are formed by fitting those key election steps, those functions together, and then that those can be realized as manufacturers choose different technology to implement it. Standard has been organized to be technology neutral more so than in the past, and so it can evolve smoothly with changes in technology. And so the second bullet is just to really try to encapsulate the essence of the standard in about just a couple of bullets here. And we'll be going over several of these sections today. The essence of it is that we want to be able to look clearly at a given voting system implementation to clearly perceive its intended functions that are implemented there, and to determine whether or not those functions that support an election process are correct and accurate, they're correctly implemented using best practices, and they preserve these properties that we've talked about a lot in other groups, security, human factors, reliability. We'll be talking about interoperability as well today and some of the others. As we all know, when we talk about election processes here, it's consistent with the discussion of processes to date, so we won't be introducing things that aren't already there. So voter registration, of course, is not, and so forth, just to be clear. So I just have one or two setup slides before we jump in. So how the core principles fit in with the rest. So principle one, what we're really talking about is we're specifying those processes we just talked about, making sure they're correct, they're accurate, they can handle realistic election volumes, and they're testable. Principle two, we're implementing with best practices, and the rest are the properties. So processes, practices, and properties. So with that, I think the stage is set. We're ready to jump in. What we're going to have in each case is we'll have an overview slide of the principle. We'll see the principle stated clearly in the context of its guidelines. We'll tell you what it means. And then we'll just step through each guideline and its associated requirements. So before we begin that process, are there any questions so far? Okay, great. So principle one, high quality design. Oh, sorry, did I hear somebody? Okay, it must be my own headset. Okay. So the principle states that the voting system is designed to accurately, completely, and robustly carry out election processes. So this focuses on three things in its three guidelines. The first guideline is about process. The second is that we're functioning under real-world operating conditions. And so the processes, we'll talk more about that on the next slide. The second, the realistic volume and the defined limits, we'll get into that, as well as that these things are testable. This principle has 146 total requirements. So let's dig in. John has worked extensively on this particular process guideline. John, would you like to speak to this slide?
Sure. Hi, everybody. My name's John Wack. First thing is, can you all hear me clearly?
Yep.
Well, I guess I should say, can you not hear me clearly? If you hear any background noise or the phone quality gets bad, please let me know. I'm also getting over a cold, and I keep clearing my throat. So, So Guideline 1.1. So the requirements are all organized under principles and guidelines, but one other way you could look at the set of requirements is that these might be the top level. So these requirements all have to do with the stages of setting up an election and running an election and tabulating and reporting results. And, you could think of usability and accessibility and security and some other requirements kind of hanging off of these. So these are the pure functional requirements. They are in VBSG 1.0. I think they're spelled out a little bit better in VBSG 1.1, which was influenced by the 2007 TGDC recommendations. So they build on those requirements. I think they're a little more complete, and they jive better with security-related requirements, especially when it comes to equipment setup, logic and accuracy testing, opening the polls, casting, so on and so forth. And I'm not sure what else to say about them. They've been reviewed fairly well by the Interoperability group, and they've actually been out there for a couple of months for review. One thing I will note is that in election definition, in casting, ballot activation, reporting results, these all require use of the common data formats that NIST has been developing. So for election definition, for example, an election management system or whatever system is being used to define the election is required to have the capability to import a common data format file that has candidates and contests and other items necessary to set up the election. In casting, there's a common data format for cast vote records. So there's a requirement on devices being able to export cast vote records. And in tabulation and reporting, there's also a requirement for a common data format for election results reporting. And the requirements are that the device or the voting system must have the capability to import or export. It doesn't say that you must use it only. A manufacturer still may have their own particular format, and that can still be used. It's just, in addition to that, having the capability. So with that, are there any questions? I'd just say these are fairly easy requirements to read, in my opinion, but a good number of them. So any questions I can answer, or do we need to do a deep dive into the requirements?
This is Judd. I don't think we need a deep dive. I think you're right. These are pretty straightforward.
Okay.
This is Lori.
Well,
agreed.
So with that, and in the interest of time, Ben, let me turn it back over to you for the next guideline.
Okay, great. So for guideline 1.2, so 1.1 is we specify our processes, and in 1.2 we make sure that that they function accurately. The system functions accurately under real-world operating conditions. In this case, this ties back to traditional notions in our previous standards for accuracy, volume testing, logical limits, like in the TDP. Anytime you manufacturers create a system and submit it to the EAC in the labs, you say, yes, my system can handle these max numbers of ballots to be counted, possible numbers of the counter capacity, the number of ballot styles, and so forth. So those limitations sort of define the boundaries of capability claimed by a system implementation. The volume testing was historically derived from the California volume testing protocol inspired there. It specifies a medium complexity election, I believe roughly about 120,000 votes to be processed there. And so what this section's requirements are essentially expressing are that the system can pass tests for accuracy and reliability benchmarks, for misfeed rates, for optical scanning equipment, and that relative to those logical limits, that it can respond gracefully when it approaches those limits and not fail in an uncontrollable way. And handling realistic volumes is just kind of continuing. So a lot of this is really just continuing a lot of the good wisdom that has sort of been established in the practice of the domain of elections itself. John, I don't know if you might like to speak a little bit to some of the thoughts that are currently occurring with respect to, say, the accuracy and reliability piece in this area.
Sure. These are requirements that I found difficult to deal with because the requirements as written in 1.0 and 1.1 mix kind of the requirement into how it ought to be tested. And we were trying to really kind of have a requirement and then separate that from the test method. 1.0, when it came to volume testing, let's say reliability testing, had kind of like a 7-day operation where the device had to operate for 7 days, and I believe it had to be in a humidity temperature container, and it was fed a certain rate of ballots, and there was also, I think, an error rate of 1 in 10 million ballot positions. And then 1.1 differed in that it got rid of the 7-day volume test, and it recommended that an analysis of reliability, it required that an analysis of reliability be performed by the manufacturer, and then the test lab must work with that and, evaluate that. And so it was getting away from the volume test. So what we ended up with, working with the testing group, is a hybrid of the two. We did separate out the volume test from the temperature and humidity, so that the temperature and humidity test typically was 24 hours. And so renting a test chamber that deals with temperature and humidity is expensive, so we separated out the two. You can do, temperature for 24 hours, and then you can do the longer volume test in probably in the test lab itself, test lab facilities. We believe this is a good mixture, but we're also sensitive to the fact that systems have to be tested in a uniform way, and at the same time, there may not be production-ready units at this particular point. We can't require that a lot of them be there. So we have to have a realistic test that can be repeatable, that can be executed without without tremendous expense, but at the same time, is effective. Accuracy and reliability are also measured across the entire test campaign. So any requirements that aren't satisfied or aren't satisfied well feed into this analysis of accuracy and reliability. So within the testing group, we have a draft, and that is going into the larger collection of VVSG-related requirements. We may continue to work on that draft to get to the point where we think we're completely done. But I believe the draft right now, as it stands, is fairly good and fairly stable. Any questions I can answer? Okay. Take it away, Ben.
All right. Thank you, John. Okay, so moving on to Guideline 1.3. It says the voting system design supports evaluation methods enabling testers to clearly distinguish systems that correctly implement the specified properties from those that do not. So it's essentially about making sure that the elements are there to ensure that a system can be tested by testers and evaluators. Essentially, we have ingredients in the VVSG 2.0 that relate to former standards that support this, and we want to continue to support that the standard expresses a conformance clause so that any user of this standard, manufacturers, test labs, EAC certification workers, etc., can know what the basis of conformity assessment is, as well as the implementation clause that anyone building can say, yes, this is what I've built, and this is how it relates to what conformance means, and then supporting documentation, especially to support that evaluation. We want to continue the practices of providing full system information in the technical data package, the TDP, and related technical documentation and test information. And so these support the need for the standard to facilitate this mapping of requirements to implemented systems and for testers to be able to make these determinations clearly and ambiguously, recognizing the functions that support the election processes, the functions that were implemented, how they're realized, how they can be observed, and how their properties can be observed in testing. And so in this case, this section is still undergoing a little bit of evolution, but the essential pieces are there. We've been in former standards such as 1.0 and 1.1 and the 2007 recommendations, you usually saw kind of a three-part act there, if you will. You had equipment requirements, documentation requirements, and test requirements. And these traditionally sort of put requirements for different parties and different elements all in the same place. And so we've been in discussions to try to focus on the VVSG having system-specific requirements and to move requirements that are primarily for testing and documentation, say, to the EAC manual. So we've been in discussion about that. And in that way, that may actually, we're hearing that may help resolve some possible duplication where there may be some of that material that has already been in some of the EAC manuals. So it could reduce some duplication that historically may have been there. And so our hope is that as that solidifies, that we can make sure this section squarely points to that, so anyone who needs to know where all the information is that applies to this principle, they can find it either in the conformance clause and implementation information here, or point directly to where the TDP and related testing information will be located in the EAC manuals. And we'll definitely be happy to keep you guys fully up to date as that materializes and include all of that information as the drafts continue to be updated. John, did you have anything additional to add to this particular one? Any thoughts?
No, Ben. I'm good. Thank you.
Okay. Are there any questions in general? Okay. Moving on to Principle 2. So as before, this is the overview slide for the principle here. This is about applying best practices, and this includes best practices in hardware, software, telecom data quality assurance, and configuration management. These are traditionally primarily the technology-oriented aspects of the standard. We've got 7 guidelines here and 85 total requirements. And I would say here that, so as we continue, I'll continue to try to just reinforce sort of the intended purposes of these different principles. So Principle 1 is kind of teeing up the essence of what it is that you're building. 2 is the essence of how you're building it. And in Principle 2, you might think of it in kind of split 2 ways. When we think about best practices, there's some engineering wisdom, such as software engineering ideals, that they kind of stand the test of time. They're fairly good general guidance that evolve pretty smoothly as technology changes. And then there's some other things where they're best practices in the sense of the latest thing that's happening, the latest coding conventions. There's new languages that come out, various new development paradigms, and so forth. And so for those cases, we ask, our strategy here is to ask manufacturers to document what those practices are in the TDP and to describe how they've been followed and how they were chosen and so forth, so that all that information is made available to the test labs and the EAC, so that we have a nice balance here between kind of general condensed technology wisdom versus the stuff that is highly variable but still very important. So the key guidelines here, the first one is general, about general best practices. The second, Sharon covered in her last telecon. That's about user-centered design evaluation. And then the next couple, 2.3 is about logic. That's really anywhere you have software. 2.4 is about structure and how you organize the components of the system. 2.5 is making sure those preserve their integrity. 2.6, how do we deal with failure? And 2.7, these things live in an environment, and how do we still carry out our functions accurately there? So Guideline 2.1, it states the voting system and its software are implemented using trustworthy materials and best practices in software development. This is essentially about engineering and implementation best practices. So we have a tie back here, as with most of these, to the best that we saw in previous standards. As you can see there, you'll see requirements dealing with acceptable programming languages and conventions. This is the high-level wisdom that is not intended to constrain so much as, you must use this language, for example. But it's if you think of each requirement as trying to solve a certain kinds of problems, the kinds of problems that we want to solve in general with respect to programming language and conventions is we're trying to make sure that they're well established, that they're in the public space. We're trying to avoid situations where, say, maybe a programming language is kind of implemented from scratch and doesn't have a lot of support yet, maybe isn't very mature. And the reasoning behind this sort of thinking is more or less when we make a submission to a lab or to anyone who's evaluating, we want to facilitate not only the quality of the implementation, but also the quality of the evaluation. And when you have things that haven't matured in the public space, the support for developing them, for the tooling, for verifying the language itself, that support just isn't there. It increases the time and the cost. And so these general kinds of things are there for language. For coding conventions, we can think of them as styles that apply to particular languages. And when followed by a team, they really tend to increase the quality, both in the consistency of the development of the code, and because of that, it also makes it easier to evaluate for the same reasons. Requirements about build quality and high-quality products and parts. Again, these are general kind of workmanship guidance here. These are trying to address questions of, so you're building a system and you get a particular hardware or software component from someone. You want to make it part of your system to support a certain function. Maybe it's an off-the-shelf scanner or printer or something like that. And so this is saying, well, if you get these things and you incorporate them, that you need to make sure that they can be integrated in such a way that they can support the requirements of the VVSG. So they can support everything from the ranges necessary to perform in their physical environment. They can handle the volume expected of them, et cetera. So we're hoping that these are relatively straightforward, high-level technology guidance. Durability and maintainability, you've seen these before. These have to do with, of course, that the systems, as well as their records, they have to not deteriorate over time. A reasonable time, say 10 years, I think is what we have in the requirements, so that they can support any processes that might use those, anything from recounts to audits, et cetera. Do these seem pretty straightforward to you? Do you have any questions? Please let me know.
Hey, Ben, this is Jed.
Yes,
so I did have a question about this one. So I was taken with verified voting's note about including some established security protocols in this language. Was there any thought given to including that in sort of the overall guideline language or in the requirement language of putting something in about utilizing established security protocols?
Oh, thank you, Jed. So you're referring to the VVSG2 Principles and Guidelines comment review period, right?
Yeah, I am, yes.
Yes, great. So yeah, thank you for that. So yes, we did go through those and have a look at those. So I believe that language is it's being finalized at the EAC. With respect to your question, though, so we did have a look at all of that, and we thought about what this means in the context of both the requirements here and throughout the standard. And I believe the wording on this one changed very slightly, but not significantly. And I think our thinking on this was simply that we believed that concern was actually sufficiently addressed when you take the whole into account. And so, for example, what you will see throughout both, I think, Principle 2 as well as some of the security principles, things that reinforce that theme across the VVSG of using appropriate software assurance methodologies, and so it's definitely been something that has been in our minds as we've gone through this process. Does that?
So I don't disagree. Yeah, and I appreciate that. I don't disagree with that. I guess what I'm saying is, given our current posture, building that in directly into the language sort of makes sense to me. And we sort of tiptoe up to the line using words like trustworthy materials, because I think that says something. When I read it, it says to me supply chains, and it speaks to those kinds of issues. But I'm certainly open to the idea of being more explicit and identifying the need for robust security in the actual guideline. So I get where we've gone with this. I'm just saying that for me, I would be accepting of something that included that explicit language.
Right. I appreciate it. I'll just offer one more comment, and then certainly anyone else might have on this, I'd love to hear. I guess the only other comment I might make, just kind of in general in this case, as well as we look at any other case, is that those priorities are certainly front and center there, and one consideration when thinking about the specific language at the level of the guidelines and principles is thinking about the long-term intent of those particular statements, and that they're intended to be high level to promote that smooth evolution over time. And so I guess sort of the line that is walked for all of us as we think about how to architect those particular statements is, what statement will A, stand the test of time in general, and B, will allow us to be as specific as we need to be within the scope of that statement, say at the requirements level, et cetera. And so I feel like that's sort of, in my mind, the conversation on the table when concerns about language are raised. Anyway, if you have any more thoughts, I would love to hear.
The one thing I guess I would add to that is that given our current situation, it seems unlikely to me that that security, sort of external security issues, would cease to be all that relevant to our work in the next, say, decade of usage of VBSG 2.0. So I don't foresee that would become outdated language and difficult to employ, because it does sort of naturally segue into established standards for creating and implementing software design. I mean, that is sort of one essential element to the building of good software. So I guess I wouldn't see it as something that would ultimately be outdated or difficult to implement or create regulatory structures which would cause the industry to struggle. So that's why I think that's why I'm sort of drawn to that language. But I'm certainly open to hearing what others have to say about it.
Hi, Jed. This is Mary. Thanks for the comment. I do. I very much agree that the question is, where do we put it? So I just sort of scrolled down, looking more at the cybersecurity requirements to see if we actually had a high-level clause in there. And we do have some things there, but I think we do need to go back and look at it and say, okay, this. I think part of what you're talking about is, particularly in this principle, saying something about building security in from the start, building security into your design. And we do actually have that for usability. So perhaps we do want to call it out for security as well.
And that's exactly why this seemed like the right place to put it, because it is about a design principle, not just about cybersecurity, but how you are building from the start. So that's where that comes from.
And I would say you'd probably want to echo those phrases in every aspect. And that way you're not calling into question which components or which pieces of the requirement security is important to.
That's a good point.
I'm sorry, who was that speaking?
This is Lori.
Okay, sorry, Lori.
Thank you so much.
Thank you.
Hi, Ben. I have a couple of questions on this part if we're ready to move.
Yeah, sure.
Are there any requirements in there that any part of the system be implemented using memory-safe programming languages?
The requirements are, there are some requirements about the integrity of memory, and I think you'll see actually another principle or so down where we do talk about safe, defensive sort of software assurance style programming methodology for addressing those kinds of things, where you talk about handling things like overflows and that sort of stuff. Is that what you're referring to?
No, actually, that sounds like the practice that developers use as opposed to the choice of like programming language using either memory-safe language or compiler-enforced automatic balance checking, that kind of thing. So that might be something to consider. I don't know whether I'm necessarily advocating for it, and certainly not for every part of the voting system, but because buffer overruns and memory safety vulnerabilities have been a problem, this is now a defense that wasn't mature or available, let's say 10 years ago, but now it could be considered. So that's one that I'd raise is, I think, worth thinking about.
Sure.
A second one that I'm wondering about is what's the status on the requirements for block structured exceptions? So I know that past versions of the standards have required a language that supports block structured exceptions, and then that's had some implications for people who are developing using C, where they had to retrofit in some, kind of unusual way to add on that support onto C, and there were some arguments in favor of that, and also some concerns I've heard raised about whether that was overly restrictive on developers, and whether that was worth whether the benefits were worth the impact of that. Where do these requirements stand on that?
Those are actually in another guideline, and I would say we could speak to them now, or actually we'll get to them in a second. But just to respond quickly to you, so we have preserved currently the block structured guidance, and I'll at least present some of the rationale, the thinking that went into that, and I would love to capture some of these notes that you're raising and continue to discuss it if we don't fully reach a place where we've talked about everything that's important there. So I think that maybe one or two guidelines down is it okay to pick up some more there, or?
Sure, yeah. And the third one is about
yes.
comments.
Yes.
So in past standards, we've had some requirements that vendors put a lot of comments in their code, and I can understand the rationale for that, but having done some source code review of voting systems, my personal experience was I'm not sure those requirements actually had the payoff that maybe we were anticipating or hoping or expecting at the time. It ended up being what I read when I was looking at source code was a lot of cases where it's almost boilerplate comments. It really looked to me like it ended up being, I don't know, I can't read the mind of the developers who are writing it, but from reading it, it looked like if I were a developer, I would be thinking, wow, this is a silly requirement that is forcing me to do something kind of pointless, and it's not really adding any value, and I have to check off this, bureaucratic checkbox that says every module and every function shall have a comment stating these things and that things and the other things, and then those comments often didn't end up having information that was really very useful for me as a source code reviewer, and I don't think would have been very useful for software maintenance. So I wonder if we might reconsider the requirement for comments in the code to tone that down or remove that if in light of that experience.
I very much appreciate that, David. Yes, I've had a number of conversations over the years on this topic too, and I know that this has sort of been on the minds of many folks out there. I think our intent was to really make it less onerous this time around, as well as to really focus on, the comments are, the purpose of comments is that you as the developer, the reviewer, the maintainer, the user, you sit down, you look at this thing, that you pretty quickly have a sense for what it does, why it's supposed to do it, without having to necessarily read through the entirety of the code. And then, you should be able to focus from there on seriously what the code does, its execution, and the reason the code's there, right? So I'm in full agreement that those are very important things to make sure we've addressed. We do have in another guideline down the requirements on comments, and we will revisit those just to make sure. We can even pop into what we've got if you want to pull up the draft at some point through this call. But I've made notes on everything you've said there, and we can follow up with you guys on just making sure that we've had that look based on this conversation, as well as does that look like it has sufficiently addressed what you've brought up. Does that make sense?
Yeah, thanks.
Sure. Are there any other comments or anything on this particular guideline?
Hey, Ben, this is Jerome.
Yes.
For the callers, will you just please identify yourself when making a comment? We'd appreciate that. Thank you. That's all.
Okay, great. Thanks, Jerome. I've just put this slide in here for continuity. As we said, Sharon Leskowski did cover this guideline in her previous briefing, and it's about human factors best practices in manufacturer testing. So we won't repeat that review today. So Guideline 3, here we're getting into some of the stuff that David brought up earlier. Thank you, David, for that. This is all about the code, all about the logic, and about all the concerns that one has when creating and developing that. Is it clear and meaningful and well-structured? Does it have good syntax and semantics and structure? And so, yes, as David mentioned, we have historically, we've brought in some of the guidance here on block-structured exception handling and some of those kinds of things. I think just to kind of put on the table some of the rationale that went into at least these in the beginning, and everything that David said, makes a lot of sense for considering, does this introduce, for example, difficulties with particular languages and stuff? We would want to know that. But part of the rationale was, again, we said requirements solve certain kinds of problems, and so these came into being in thinking about cases where folks didn't use a block-structured or regularly structured mechanisms for exception handling, and where there were ad hoc structures and they weren't easy to follow. It wasn't clear or meaningful necessarily when you dig into the code really how this is handled. And so the main point then was that there should be some repeatable, reliable structuring to these mechanisms. And I think that was really the main intent for those requirements. So similarly for things like control flow and stuff like that, everything in this section is really about that we have consistent structure and that it's clear so that you can find the structure of that control flow as well. Before I just talk about the wrapping and the other ones, David, does that rationale does that make sense at the higher level at least?
Well, Dave Wagner here. Well, I understand what you're going for, but I don't think it really is, from my perspective, addresses the issue. So, I mean, of course, absolutely, the high-level goal makes sense, but when we look at the, okay, I'll get specific. I think I would advocate that we remove the requirement for block structured exception handling. And the reason is, I think I can understand the benefits, but it's not really clear how much benefit we're getting from that one specifically, and we know that it imposes some cost on developers. To me, that one, the cost benefit, just it doesn't seem clear that it's there. So I'll just throw that out there as an advocating for removing that particular requirement. And it's not something I'm going to go to the mat on, but I think it would be better for us.
Okay, I really appreciate that, David. We'll certainly return to that and revisit that, and look forward to your feedback as we go through that. So thank you. Just some of the other requirements here, they essentially reinforce these same themes. Wrapping legacy code. If you had former tools or components, and you're incorporating them into your system to ensure that they're incorporated in a well-encapsulated way and that they integrate well with the system. Separation of code and data. The problems this was thinking about had to do with concerns where you might have executable code, say, hidden within data or embedded in data. And we see this pattern show up in a lot of attacks. And it's not really the cleanest design either. We can accomplish what we need by separating these things. So those were the intentions for those kinds of things. And so this is the essence of this slide. Are there any other questions about this particular slide? All right, thank you. Moving on. So Guideline 2.4, this is about modularity, essentially. And so when we design a system, and often folks will speak of a system as a set of elements that work together to achieve a function or a task. And certainly the functions, the tasks, are the processes, the election processes that our systems support. And in this case, the elements are our software components, our modules is the word that we use. And so when these elements are made to be like interchangeable parts, and so it's easy for folks to maintain. If something breaks down, it's easy to put something in there to access it. It makes it easier to scale the system. It makes it easier to test it. And so some of the traditional guidance in making modules is merely about, if they get too big, maybe they're clearer as separate, smaller modules, because the point of modularity is also to sort of control the complexity of the system, keep it reasonable and meaningful, and that we can identify each part. Things like lookup tables, objects like that can often get fairly big. So it's that same theme of trying to separate out things and keep the elements clear and clean and meaningful. Are there any questions about this one? All right, thank you. this slide, we get into some of the things that David Wagner raised, as well as the theme of general integrity. In particular, this guideline's about that the voting system supports the processes and data with integrity. This has a pedigree to former standards, and so here we're talking about data, anything from vote data to audit data, that we're protecting that from unauthorized change. We're ensuring that if we transmit it, something changes, that we can detect that change and potentially correct it if necessary using appropriate correction codes and algorithms. It also involves some of the kinds of defensive code practices that kind of came up on the call earlier for software assurance. And so we're talking about not doing things that generally don't promote the stability of the software base. So if you have code that if every time it runs it's not the same code because it changed itself, that's not what we want. We want code that each time you run it, it's the same code, it does the same thing. So we avoid self-modifying code. Code that runs processes at the same time, concurrent code. We want to follow safe practices on that to make sure that they are stable. We follow general guidance about code integrity. So a lot of this has to do with the kinds of things that I think both Judd and David were alluding to. We're talking about best practices here in validating your inputs, scrubbing your outputs so that information that flows through the system can be seen as valid by the components that have to use it. This deals with traditional best practice guidance and error handling and covers common cases like buffer overflows, numerical overflows. So again, we're talking about software assurance practices here. Are there any questions on this one? I would point out that this particular guideline is separate from a security-related one that Gema will have. This one focuses on how things are made, how you build and execute particular components. Hers is about the integrity of system installation over time. So are things installed in an authorized way, in a correct way? So these are different focuses on integrity. So we just have two more for Principle 2. 2.6, so we just kind of reviewing what we've done so far. So we make our processes, we ensure they're accurate, and we build them with best practices. We protect their integrity, and then sometimes errors and failures still happen. Sometimes a component fails. Sometimes hardware failures happen. You might have issues during transmission, et cetera. And so this is where we talk about how a system should deal in general with failure and error cases. So we want to be able to survive device failures. During failure, we don't want to compromise our data, whether it's voting or audit data. We want to be able to survive failures of particular components so that that system and that process can continue on. And so that we can also recover in a controlled way. And so that's the graceful piece, that if something fails, that you'll have a way to know what happened and if possible, have a way to actually correct it and continue going. So again, this draws on fairly general guidance that's been present in existing standards so far. Do you guys have any particular questions about this? Okay, great. So the last guideline in this principle this deals with the physical environment piece. So as election equipment and processes carry out their tasks, they may be operating or stored or transported under a number of conditions. We all know them well: temperature, humidity, etc. When you're moving things, they can get jostled, whether it's vibration, sometimes dropped, hopefully not often, so that's shock. And they may be subject to electrical disturbances. And so under all these different kinds of stress, this guideline has requirements that strive to ensure that the system continues to be stable even in the presence of these kinds of conditions. Again, this has a pedigree through the other standards. There's been some particular work that I know John Wack and others have looked into some of this. John, did you have anything to add about this particular piece?
The only thing I would add is with regard to the electrical requirements, there were some complaints from manufacturers who felt that the electrical magnetic, the ability for voting systems to withstand electrical interference and not to produce it, were really more or less inherited from the 1992 standards, and it's expensive testing, and with increased use of COTS, does it make sense to really do things in the lab and test things that aren't really showing up in the field? So we opted more for simplifying the requirements and essentially stating that devices that are going to be out in the precinct or being touched by humans in a polling place need to conform to Class B electrical requirements, and for a number of reasons, Class A is acceptable if you're dealing with central scanners and a number of devices like that generally do not have Class B certification. So the attempt there is to reduce the cost of testing and make things more practical and rely more on well-established standards that are out there.
Great. Thank you, John. Does anybody have any questions on this particular one?
So this is Dan Wallach. Just a quick thing. What's interesting here is that for the physical requirements, we seem to be talking about like something that's, externally verifiable. You can put it in this temperature or drop it this far into the concrete, whatever, and it's going to work. Whereas for the software, we don't seem to have an equivalent set of guidelines that are saying it shall be resistant to this and this and that class of bug. Instead, we seem to be more prescriptive about how they should do it. Does that make sense? Am I missing something?
I apologize, Dan. I caught part of what you said. Did I hear you correctly in saying that the physical requirements seem to be, you said sort of, what was your language? It was more concretely.
We're not telling you how to make your box survive temperatures and water, and we're just telling you that it needs to survive certain physical environments.
Right.
Whereas for the software, it seems that we don't have a similarly, you have lots of ways that you can do it, but it needs to be done properly.
Right.
Am I correctly reading the difference here?
So it's an interesting comment. I'm just kind of reflecting on it for a moment.
Hey, Ben, John Wack, and I'm wondering if I can jump in here.
Sure.
Just very quickly. So yeah, that's a valid comment. I think the intent was to have the VVSG contain well-established best practices, but also to not be too prescriptive. So there's a line you have to walk, and if you and others have specific comments on how we can simplify that or walk the line better, we'd be very interested.
So, Dan Wallach here. I managed to hit the hang up button rather than the mute button, so I'm afraid I just missed everything you said. I'm so sorry.
Okay. The idea was for the VVSG to have well-established best practices, but not to go farther than that and rely more on requirements that are more along the lines of what you're stating. There are a number of ways to do it, but it has to be done properly. So there's a line you have to walk between being too general and being too prescriptive. So in these areas, these are way down in the weeds requirements, so to speak. So it would be helpful to, down the road, get more specifics from you and any other TGDC members as to how we could improve them.
Fair enough. Thank you.
Thanks, guys. Are there any other comments on this particular one? All right, thank you. I think we're to John's principles now.
Okay. Well, I've always been told that watch out when a preacher says, I'll try to be brief, because then you're in for a long sermon. But I really will try to move things along here because I think these next two principles are relatively simple. So transparency, it doesn't work to have a requirement along the lines of the voting system shall be transparent. And it's a quality that's pervasive. In Principle 3, there are some requirements that address transparency as best as we can concretely do that. But there are requirements elsewhere in the VVSG that also have to do with transparency. There is a lot of noise in their phone. Thank you. So usability, for example, has a lot to do with transparency. So the usability requirements, in different principles have a lot to do with this. But in here, we put more into documentation and setup inspection, and the fact that the public in demonstrations of the voting system can understand and verify the operations. But the overall goal is to have a design that is, I hate to keep using the word simple, but that is structured in a way that it is not difficult to understand it, to make modifications to it, that it's resilient in that way. And the way in which the voting system operates and the way you have to manage it, that should be relatively straightforward and understandable. And the documentation surrounding it has to be very understandable and usable. The idea being that if there are security controls and they're important controls, but they're difficult to use or they aren't well explained, then perhaps those controls may as well not have been there. So it's important here. And the other thing, kind of at the basis of all this, is briefly, I can't recall if Linda Limon is on the phone, but 15 or so years ago, I remember talking with her where she was unhappy about having to rewrite the manufacturer's documentation. So the big idea here is that the documentation be complete and be readily understandable. Ben, could we move to 3.1?
Sure.
So I more or less have covered it. In the interoperability working group meetings, I emphasize that, more or less election officials, here is your opportunity to make the voting system more understandable and more usable. Give me your comments regarding these requirements. And I got some. upon further review, if there are more, I'd be happy to make those. But the other thing I'll note is that we're focusing on the documentation that the manufacturer has to provide to customers. And we're separating out the documentation that the manufacturer has to provide to the EAC to participate in its certification and testing program. So those requirements will be handled in the future in the EAC's testing and certification program, and we're focusing here mainly on, customer type documentation. Any questions before I move to 3.2? Okay. Ben, could you move to 3.2, please? So setup inspection is, logically speaking, way back in Principle 1 with the requirements that address, the various stages of an election and what the voting system is supposed to do. But they're located under here to emphasize that setup inspection has to be something that is, again, relatively simple to understand and to demonstrate. So, if you want to understand that things are in a secure configuration prior to opening up the polls, these requirements deal with that. And they get down into the weeds. This is another area where, again, if you have specific comments, I'd love to hear them. Any quick comments from anybody?
Yeah, can you give an overview of where the setup inspection stands compared to, so just by way of, Dave Wagner here, by way of background, VVSG 1.0 and 1.1 had some modest requirements here. The previous iteration attempt at writing VVSG 2.0 had very strong requirements that were potentially quite burdensome. And where the current stuff stand on that spectrum?
Well, when you say 2.0, are you talking about the 2007 document?
Yeah, sorry, yeah.
Yeah, in 2007, that is the area where the requirements were strengthened a good deal over the other, election definition and, casting and counting requirements. So the majority of these requirements are very similar. Now, if you feel they're too burdensome, I'd love to talk to you more about that because the goal here is to make these requirements hit the right balance.
Dave Wagner again. It would be interesting to hear from vendors and manufacturers what the feeling on this is. My opinions on the 2007 style setup inspection requirements were that, in retrospect, I think we might have gone too far, and I'm worried that they might put a lot of burden on vendors to have hardware support for TPM style support, this kind of thing, in their hardware design that might restrict their ability to build things, and concerned that the security benefits from this particular one might not have been as great as the costs there. And I'm cognizant of the downsides of having a standard that imposes a lot of costs on vendors. So I would be curious to hear what the perspective from the manufacturer, the vendor community is about the implications of that from cost and constraining innovation and yeah.
So John,
Mike,
John, this
is
Mary.
Gema.
Is this something that you can bring up with the testing group in one of your upcoming meetings?
Yeah, you took the words out of my mouth. So we've got a testing group going. I'm one of the co-chairs along with McDermott Coots, and we've been focusing more on the benchmark requirements to make sure we have a good draft of them prior to the upcoming TGDC meeting. But the overall aim is to look at requirements like these and examine not only whether, as written, they're testable, but whether they're really doing what we need. So you could look at it to some extent as a requirement review process. People have brought up that various requirements in the VVSG they think are untestable. So we've had some manufacturers in one of the test labs on the phone calls, and the discussion has been very good. I want to praise the manufacturers that have been on the call. I feel people are really kind of talking about here's what we ought to do as opposed to here's what my company ought to do. So I'm glad you brought it up. This is an excellent area for us to take a look at. And if there's any way you could be on those calls, I'll let you know and when we address those, because your feedback would be very helpful.
Hey, this is Gema. Could I make a quick comment?
Sure, go ahead.
Sure.
So just in reference to David's comment, that concern came up on the Cybersecurity Public Working Group calls around, the 2007 VVSG recommendation for the hardware security modules, or the TPMs, and within the requirements, at least on our end, we actually ended up not specifically requiring that to be implemented through a hardware module. So I don't know if John, you have anything different, but I know on our end that specific requirement, with those concerns in mind, we definitely had that discussion around cost and the burden around including that specific aspect. But I don't. As far as I know, within our requirements, we ended up not including that specific requirement in the updated version of the VVSG 2.0 requirements.
Okay, thank you. Any other comments about 3.2 before I move on? David, I'm just glad you brought that up. That's a good, I'm glad you did. So Ben, could we move to 3.3? So this particular guideline has requirements that, they're fairly straightforward to read. They have to do with system event logging, for example, making that more transparent, producing publicly available documents that describe what the manufacturer's codes are and what they mean when reading the log file. The intent for all of this is that, some startup company who wants to work for a state and, do auditing or whatever and get some contracts can readily obtain the information they need to be able to understand event logs and other information about the voting system. So going on, this area also talks about not only do you need to have the capability to use common data formats, but you must provide documentation on how you implemented it. So it's not enough just to use a common data format, but you need to actually kind of provide kind of a user manual so that someone can readily write software to take an import and understand what it means. The other areas have to do with encodings, I guess. And this ultimately has to jive well with the cybersecurity requirements. The idea is that if there are any encodings being used, barcodes, whatever, that number one, they they shouldn't be used unless they have to be used. But number two, well, and that's a judgment call. But the idea is that if it doesn't need to be encoded, it probably shouldn't be encoded. But if it is, that the encoding use some well understood, well documented standard. If, for example, there's a barcode used, then it has to be a standard barcode. If the data that's put into the barcode is packed, then the information on how the data was packed has to be made readily available. And I think the last requirement really has to do with audit, and this as well has to be jived with the security area completely. But it's simply a higher level requirement that essentially says the documentation surrounding how to audit the system has to especially be very well written, very understandable. And stepping back for a second, these requirements in general regarding documentation probably put more of a burden on the test labs where there may need to be a better understanding of plain language and how to deal with that and how to write it. But I think in general the requirements push that the better documented the system is, the better it's likely to work and the more secure it may be. So, any comments on that? Well, fantastic. Let's move on to number 4. 4 is obviously interoperability. The idea sort of carried from the 2007 effort. In 2007, there was no clear common data format available for election data. So 2007 had a number of requirements we called should requirements. You should use a common data format. The idea was that it be easier to have a certified system and swap components in and out. The EAC has for a long time wanted to move its testing and certification program to a point where that could be tested. So that certainly would save quite a bit of money for states and would leave them less locked into any one manufacturer. So here, Ben, if we could move to 4.1. Here's where essentially in a voting system, the common data formats have to be specified and their usage be documented. So briefly, a common data format regarding election event logs, one that handles election results reporting but also handles election definition information, one around cast vote records, and the other one around voter registration related data. It was originally intended to address voter registration portals, online voter registration portals, and interactions between those and voter registration databases. It could handle interactions between voter registration databases and electronic poll books. So fairly straightforward requirements about that. Any comments? Okay. Could we move to 4.2? So if there is not a common data format available, use some other available public standard where possible, where applicable. Again, just trying to make things as open as possible. Any comments on that? And 4.3, Ben?
We're there?
Oh, here we are. I'm sorry. My computer's lagging. And it extends the same thing to hardware interfaces. Fairly obvious requirements, but, it needed to be in there. So, obviously, you don't want a old style printer port. You want to use, USB A, B, C, something along those lines. So any comments on those requirements in general? None? Okay, well, thank you very much. I think Ben and Mary, we might be at the end of the. Oh, I'm sorry. How embarrassing! I forgot one of them. COTS devices. Essentially saying COTS devices are permissible. The 2007 standard did this as well, as long as their usage, trying to state it positively, as long as all the requirements in the VVSG that are relevant to that are still satisfied. The electrical requirements that I talked about earlier were simplified in essence to help with this situation. Any comments on that? None? Okay. All right. Well, what I said earlier applies now. We're at the end. Does anybody have any questions? Well, may I turn this back over to Mary and the colleagues from the EAC?
Sure, I'll take over. Thank you, Ben and John, and I will turn it over to Commissioner Hovland.
Off mute success, I think. Well, thank you all for that. Sometimes the hour and a half just flies by, and it looks like we finished ahead of schedule again. So this will conclude the second call on the requirements. Again, we'll have a third call coming up in early September. And as we discussed on the last call, certainly if there's any feedback if people are going back and looking at requirements after this call or thinking about issues, feel free to email those or maybe reply all on the invite list so that everyone gets a chance to see those. But really appreciate you all participating today, and we'll talk to you all soon. Thank you.
Thank you.
Thank you.